Hey everyone, Rusty Rob here. Hope you're all enjoying Codejam so far and had a good crack at 1B for those of you who did. Um, and for those that made it to round two, congratulations. Um, Hope you all managed to try win a Codejam t-shirt. Oh, I might give it a crack. I was lucky enough to get through to round two, but it's at 2 a.m. in New Zealand time, so it's going to be pretty tough. I'm not sure if I'll get up for it or not. It's pretty tough coding at 2 a.m. because, I mean, if you write code and it works first time, it's great. But if it doesn't work first time, I find in the middle of the night it's pretty hard to remember exactly what you were doing and keep track of all your variables and just comprehending the problems and things. Everything's just a bit slower, I find. But let's see. Anyway, for this video, I'll just go through a couple of the easier solutions with Rust. So yeah, I might just try code a couple of them up now. We'll see. Might have to go in a bit, but or at least go through the pancakes one. We'll see how we go. Yeah. So let me just rearrange the screen slightly. So here we go. Hopefully that's not cropped out. We'll see. Make this a bit smaller. All right. So first one is pancakes, and so we've got a double-ended queue of pancakes, and we've got a queue of customers, and each pancake has a tastiness, a level of tastiness, and every customer wants a pancake that's at least as tasty as all of the previous customers. And so they can take a pancake one at a time, either from the left or the right side of the queue until there's no pancakes left. And so, what's the maximum number of customers that we can satisfy? And so you can see here they've got 5 customers, so there's 5 pancakes, all of 10 tastiness, and so we can satisfy all 5 of them. Doesn't really matter what we do. Whereas in this one, there's 4 customers, so we want to. This one's not very tasty, so we give that out first, and then we'll give out this one, which is a 3, and then we'll give out this 4. So we give out the 4 before the 2, because if we gave the 2, actually that wouldn't matter. But if we did the 3 before the 4, um, that would be fine. If we did the 4 before the 3, sorry, then we wouldn't get anything for that 3. So basically, you can have a pointer to like the left and the right of the queue, and you always just want to give out the least tasty pancake first, because at least then it's not going to affect the more tasty one. So either you give it out for free now, or you have to give it out for free later. So it's just a greedy algorithm. So we can either use a vector with 2 pointers, one to the left and one to the right, and move the 2 pointers towards each other as we give out pancakes, or we can just use Rust Deque. So we'll just use that, which that allows you to pop from the left and from the right, and each operation is like auto one operation. And so for these kinds of things, I've just got this template here, which does my input. It's like a reader, so I can read any kind of variable. I just give it the type I want. So I can read the number of test cases, and I can use this vector method to get a vector of numbers to get all the pancakes. Just copy and paste that. And I just need to fill this out. So we've got 4 test cases. So this one, there's 2 pancakes. So that's the number of pancakes. So I'll go pancakes. Well, actually, I'll just call it Q. Vec n. This is a vec of size. And I mean, I guess I'm kind of doing double the work, but it doesn't really matter. So I'll call this V for vec, and I'll make Q equal to vec dq of V. So it's quite nice. This should have got imported automatically for me, so that's a nice thing about this C-line editor. And it's checking as I go. So that's not how you initialize. This is how you create a new empty one. That's fine. If I give it a type, or it can infer the type. But if I want to make it from the vector, then I go from there. And that's just going to consume the vector into the deque. So I've already got this variable ready to go, so that's nice. And so I'll keep taking the left and the right and comparing them. So while q dot length is greater than 1, and then if there's just one left, I'll do that separately. I need to keep track of the minimum. No, I need to keep track of the maximum pancake I've given out so far, because a pancake is only of value to a customer if it's at least as good as that. So let the maximum so far equal 0. So these are all positive numbers. So for that last case, for the last pancake, I'll just go if, so I know there's one value there. There's always at least one pancake, so q dot pop. And I can pop from the front or the back, doesn't matter which, I'll just pop from the back. If q dot pop to unwrap is greater or equal to max, then the answer will increase by 1, it's a value. And it's complaining to me a little bit. Not sure why. Cannot borrow q is mutable. Sure, I need to make that mutable. I need to make that mutable, and I need to make that mutable. Rust can slow you down a bit like that in competitive programming for these kinds of things, but actually I think it saves you time in the end. It stops a lot of bugs. You don't mutate the wrong variable. It's quite strict, and yeah, it definitely helps, I think. So now we just need to compare the left and the right each time. So if q dot front is less than q dot back, then we'll, so what do we want to do? We want to pop a value either from the front or the back. So let taken equal, so if the one from the front is less, then we'll take the one from the front. So we'll take q dot pop front. Otherwise, we'll take q dot pop back. And this is an expression in Rust, so it's quite nice and short. So this is getting returned into this taken variable, or this is getting returned into this taken variable. So that's quite nice. And so you can see taken is an option of view size, and we actually want the exact value, I guess. Although we could have actually made this maximum an optional value, I think, because when you compare two options, it compares the inner value. But we'll just unwrap. Why not? And unwrapping is just getting us the value inside. You can think of it as like null. It's possibly null because this cube, maybe it was empty, but we know it's not empty because we've got this checker. So this is safe, and so that's like using star in C++ or C and so on. But yeah, I wouldn't use unwrap too often otherwise. Anyway, so we've taken the least tasty pancake. Now, if taken is greater or equal to the maximum so far, then we can set the maximum to taken, and we can increase the answer by 1. So I think we should be done. And then I just grab the input data by clicking here, and this is the output where you should expect to see. So let's give that a try. So I'm just going to go cargo run in.text. See what happens. 2352, 2352. So yeah, so that's cool. And I guess we could generate some max test cases to see how quick this is. I don't know if it's really a little bit pointless, but we could try and make a massive stack here. What's that? 8, 9, 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000, 1000, 2000, 3000, 4000, 5000, 6000, 7000, 8000, 9000, 10,000, 11,000. I'll just hold this down. Cool. And then let's just say this is 100,000. I don't know. We'll see if this works. And I don't actually know how many I've got. So yeah, it's pretty quick. And that's just running in dev mode. Let's try build the release. Oops, typo. So we've got release, and then I think I've got algorithms. Yeah. So I'll just time that. Oops. New keyboard. Okay, so time that. So yeah, pretty quick. So that's usually going to pass. So I guess we could go to the next question. It's a little tricky. So this one, we've got N customers. Each customer has P products. So let's just say P is 100, and let's say there's 50 customers. So you have 50 customers. They each have 50 customers. Each has 100 items they need to pump up with the air pressure, and each product requires a different air pressure potentially. And so you have to adjust the air pressure by pressing minus or plus each time between products. And you want to go through all the customers in order, but you have to think of an ordering for the products of each customer. So you want to minimize the number of button presses. And it starts at 0, the pressure. So I think if you think about it, you just have to sort all the products of each customer by pressure. And then, so either you'll start at the lowest pressure, you'll adjust the machine to the lowest pressure, and then go to the highest pressure, and you can just get all of the items as you go from low to high, or you might go from high to low. And then, so customer 1 will just go from low to high, obviously, because it starts at 0. But let's just say we're at the ith customer. So let's say customer 10 comes from customer 9. So either the customer 9 will leave the pressure either at their highest or lowest of all of their products. And then, so customer 10, we can solve for both cases, like the highest or the lowest of the previous customer. And when we're solving for the highest or the lowest of the previous customer, we know how many operations it will take from the previous customer to get the 10th customer, the current customer, to their highest or lowest. So basically for each customer, we can keep track of how many operations it takes for them to get to the highest pressure or lowest pressure of all of their products, by using results we had from the previous customer. And so that's basically dynamic programming. So even though there's, you know, many, I don't know, let's just say trillions or more than that, different combinations, it'll be quick. So that's good. I guess, wait, how many combinations are there? I guess each customer could be high or low, so that's just like a 0, 1. But so it'll be 2 to the power of how many customers there are. So 2 to the power of n. And this test case n is 1,000. So yeah, that'd be too slow. So that's why dynamic programming will help. So it's just going to be order n instead. So it's just going to be 1,000 operations. So they could have made this 1,000,000, this number, but maybe they were just trying to be tricky. They're like, if it's less than, if it's a smaller number, sometimes it's harder because people might try to do some less efficient algorithm or something like that. Whereas if they made this 1,000,000, you'd know you had to do like a linear time algorithm, and that actually simplifies things a little bit. You know, I guess we could try code this up. It's maybe a little tricky. You have to kind of work out the distance and stuff. Yeah, I'll give it a try. So I just get rid of this. I'll just copy this in. And I'll just copy my template across. So put that in there. So N, that's the number of customers. P is the number of products. I think it was N and then P, yeah. So let's copy that. P is the number of products. And then we need to read the products. So for each customer, I could just name this. No, it doesn't really make sense. So let products, and we're going to sort this, so make it mutable. So we'll get a vector of size p. Each of them have p products. Need an equal sign here. And this is so much nicer coding on this new laptop. I got a new laptop from work last week, and when I record on my old laptop, it would just be really slow and it'd make it tough. Whereas now I can just code easily. So it doesn't know the type. Yeah, so these numbers can be pretty large. They're of size 10 to the 9. So for each customer, we could be going like 0 to 10 to the 9, then back to 0, then up to 10 to the 9. So it could be, and there's 1,000 customers, so it could be 1,000 times 10 to the power of 9. So that's 10 to the 12, I think. So we'll use a U64, which is like big. And it's complaining. It doesn't know if this is greater or less than, so you have to put these 2 dots. That's like called a turbo fish in Rust, apparently. Now what was it I said? Sort them. So I can just sort. I often like to go sort unstable because it just shows it doesn't really matter. Go order too much if they're equal. And then we only care about the smallest and largest product in terms of air pressure. So we can just store that in a tuple. Let tuple equal products 1. And I guess, what if, there's only one product? But yeah, the number of products will always be at least two. So that just makes it a bit nicer. Um, so I don't know what I'll call this. That V, or I could tubes. I'll just call it V. It'll be shorter for later. And if we really wanted to be efficient, we could go with capacity, because we know that there is going to be exactly n of them. But obviously this doesn't help because n's only 1,000. But if it was like, 1,000,000 or more, it can help. Why is this complaining? It doesn't know the type. But once I add this to it, tube. Now this should go away. So now it knows the type. So that's quite cool. Now what do we want to do? So you want to go through all of those in order. So I might add 0 to the start. Read out push. And that's just going to mean I can start the DP from 1 instead of from 0. Because when I go -1, I'm going to calculate each time based on the previous product. So it's kind of like a dummy first product, which is nice. Since we're starting from 0 in terms of air pressure. So I mean, if we wanted to be really fancy, we could actually pre-allocate this DP thing. So we could go, I won't do that. Sorry, that. Because each time we're overwriting values, so it doesn't really matter if there's already numbers there. I'll just build a new one each time. So, and how big does this need to be? We'll initialize it with a 0, and we'll go P plus 1. Because although we have P products, we need plus 1 because I've added this dummy one in. So for I and 1, and normally you go like this, but because we're starting from 1, we'll go 1 higher. Is this a good way of doing things? Maybe. But then, yeah, that's fun. Yeah, everything's just shifted by 1 by adding this in. So that's at the start. So, so we want to set DPI. Oh, what am I doing? So we need to have 2 values here. So we'll have this as if we're coming from the left, and this can be if we're coming from the right. So from high pressure and low pressure. So DPI 0 equals, how do we calculate this? So we want to get to the start. So to get to our left side, to finish at our left side, we must have come from our right side. So it's our right side means V. Let's just shorthand this. So let A equals V. Sorry. Yeah, we did call it V. V I 0, dot 0, and let B why is that complaining? Use of move value. Where did V get moved? Here it thinks it's getting moved, but I'm not doing that. Okay. So that's like the smallest pressure of a product and the largest pressure of product I. So dp 0. So if we end at A, we must have come from B. So it's B minus A plus we need the cost to get to B because we've just come from B to A because we've finished at A. That would have been better if I drawed some intervals or something. But anyway, so we've come from the right to the left. So that's that. But we also need the cost to get to the right hand side in the first place from the previous person. So that would be dp I minus 1, 0. So that's their cost to get to where they were. Plus we need the cost of them moving to B. So I'll make a distance function. Have I used variable do? No, so go D B. It's the distance to B from where they were. So that's V I minus 1. And they finish at. We have them finishing at their left side, so we'll take the left side. The distance from their left side to B. So I need to implement this D distance method. So it'll be A U64 and B U64, and it will be U64. We need to mutate these, not really. If A, so let A comma B. This is just not the best way of swapping. I'll show you the proper way to swap, actually. So I haven't used mem swap for a while. So we want A to be less than B. So if A is greater than B, mem swap. Yeah. And then, so now we know A is less than B, so we can just return B minus A. If I had used I64, then I could have just used the absolute method. That would have been smarter. Why don't I do that? Because we know these values aren't that big. Are they? Oh, they can fit into I64. So I haven't actually ever had to use this, but if I just go A minus B dot abs, the thing I'm worrying about is the Codejam version of Rust is really old, so I don't know which methods it has and which ones it doesn't have. And I haven't installed an old version of Rust on this laptop. Okay, I'll try that. And if I really wanted to make this nice, I could just go like this. Okay. So, where were we? So this was how we can get to, it's the cost of this is the cost of going from B to A. So we could actually just go D, A. The distance like that is maybe slightly less clear because we don't know the direction now. Unless I'm consistent with how I do this, but that's fine. So it's the minimum of this. So we could have either come from the left of the left product of the previous customer, or we could have come from the right product of the previous customer. So now I'll do the right. So the right means this will be a 1, and we still need to get to B, but this time we're coming from the right side. So we just change that. Okay, so hopefully that's right. And now I need to do the same for the right side. So I'm coming to, so this is how can I get to B, which is my right. So I need to go from A to B, so I still need this cost. And then I need the minimum cost to get to A from the previous customer, plus the costs involved in those. So that'll be, so I could have come from the left of the previous customer, which means, but yeah, now all I need to do is I'm going to A instead of B. So I just need to change these to A, and we should be good. Okay, so the answer will just be the cost of getting to the last customer, right? Well, actually, I was going to go like this, but yeah, I'll just go like that. Since this is a list, I could have just taken the minimum directly from it, but then you need to unwrap because you have to tell Rust that it's not empty. Because actually, we don't have to tell Rust it's not empty because these aren't vectors. So, maybe we still do. I'm not sure. So I'll just go like that. So, moment of truth, I already copied this in here. What are we looking for? We're looking for 110 and 499999999 or something like that. Can I go run in.text? So I reckon there's like a 40% chance this passes. Yeah, so I've made a mistake. What have we done wrong? Damn. And we should have made this. That's right. So let's just print P to debug. Sorry, print the V. So this is the tuples. We'll also print the DP. Just see if these look sensible. So I guess this looks sensible. But I mean, we should have 110 here, so we're low. Are we missing anything? So here they've got 3 customers, each with 3 products. Are we missing any costs in here? Let's see. So let's just go through this. So to get to the left should not cost 50 at the start. Actually, it would because we go from 0 to 40 and then, no, we'd go from 0 to 30 and then back to 10. So that would actually be 30 plus 20, which is 50, so that's correct. And whereas to get to the right hand side, we just go from 0 straight to 30. And then 80 means it's like, what's the cheapest way to get to 20? We can, so we can go from this, I guess we can go from this 10 to 20, and it'll just be 50 plus 10. So it would be 60. Or we could go from this 30 to the 20, and it'll cost 10. So this is wrong. So this should be 40, should it not? Yeah. So it's something wrong here. Oh, did I not change this before? That's right. So I'm going from the left. Yeah, never copy and paste because you'll make a mistake. I don't know what I've done. Or is that not 40? It shouldn't have been 40. Should have been 40 plus the distance between these two, which is 40 plus 30. Should be 70. And then we end there. Okay. Where's this? You're kidding me. I got to do this for N customers, not P customers. What am I even doing now? Go N products. And that should be N and N. Jeez. 26, 13. So that should be N plus 1. You know where I got P from. There we go. So that second one's correct. That should be 1110 though. Something a bit funny. So why did I put a 1 here? It should have been the last product. Sorry guys, I am a bit tired. I got up pretty early and then I've just been out and about all day. There we go. Alrighty. So let's just get rid of the excess printing. And you can go like ePrintLin if you just want debug output. But then if we write this to a file, and go cat out.txt. See, we just have the answer there. So that's quite nice. Anyway, so that was that. So we're just using dynamic programming. And so yeah, thanks a lot for watching. And I'll see you all in round 2.